Hello everyone, this is Ryan Rice from Washington State University, and in this video I'm going to cover how to make and use the graphs you'll need for the enthalpy of formation experiment. I'm going to do this on a PC running the 2016 version of Excel. Your own version might be a little bit different, but the concepts will still be the same. The first thing I've done is enter my data into an Excel spreadsheet. I have my pre-reaction data here on the left, and these would be the numbers you collected with the first solution you put into your calorimeter and before you added anything else to start the reaction. Then on the right-hand side, I have the post-reaction data that I collected after the reaction began. So now it's time to turn these numbers into a graph. We'll begin by coming over here to the pre-reaction data, highlighting those. Then we go Insert, Charts. We want Scatter Plot, no lines. And you can see the graph that it made for us. It's a little bit bumpy, but that's okay. That'll work itself out in the end. Now that we have our pre-reaction data, we're going to add our post-reaction data to it. We'll come up here to Select Data. We'll go Add, give it a series name. We just call it Post. Add our X values by clicking on this icon. Highlight these numbers, enter. Click on this for the Y values, highlight those data, enter. Okay. Now we have a chart with both our pre-reaction and our post-reaction data on it. Right out of the box, the numbers on our graph are a little bit bunched up toward the top, so we can fix that by first we're going to click on the, double-click rather, on the Y-axis. And if you come over here to Format Axis and you click on these three bars, you'll see an option for Axis Option Bounds. Let's go ahead and set the minimum. Our lowest temperature was 22 degrees, so we'll maybe set this to about 20. And we're also going to want to give ourselves some headspace here to work with, so we'll set the maximum, maybe we'll just go 30. That gives us a graph we can work with. Now that we have the chart made, we might as well give it some titles. If this were for the reaction with HCl and ammonia, we could give it a title that reflects that. HCl with ammonia reaction. Then to give the axes titles, go over to the plus sign, click on axis titles. The y-axis contains our temperature data, so temperature. And quick tip, if you're looking for the degree sign, it's just here in Insert, Symbol, and there it is right there in Calibri. Insert, close, got our degree, Celsius. And then on the x-axis, that will be time. My example graph is in minutes, but be careful, your own might be in seconds. Just make sure it reflects what units you actually have. Now our graph needs some best fit lines, and we're going to give it not one but two of those, one for each set of data. For the pre-reaction data, I'm going to come down here, click on those to highlight them, go over the plus sign, trend line. And even though it's a little bit hard to see, the Excel did put a trend line right there. It's this little dashed line between the blue dots. If we want to make it easier to visualize, we can just click on that, double click on it. That brings up the format trend line options, and if you click on the paint bucket, you can come down here. It gives you options for color. Maybe I'll make that red. I can increase the width, and you can see that makes it a little bit easier to see. Then for the post-reaction data, we'll do pretty much the same thing. Click on those, trend line. Again, it's a little bit faint, a little hard to see, so click on the line to highlight it, come over to the paint bucket. Maybe I'll make this one green, make it a little bit thicker. So if you look at the way Excel draws these by default, they only go so far as the range of data points that made them up. The bottom one, for example, for the pre-reaction data only goes as far as 2.5 minutes, and the upper one for the post-reaction data only goes as far back as 3.5 minutes. We, however, need them to extend out over the point where we mix our reagents together, which in our case is here at the 3-minute mark. So to extrapolate these lines, what we'll do is, if we start with the bottom one, click on that, come over here to these bars, and if you come down here to forecast, you'll see options for extending the lines, extending it forward in this case. Maybe we'll try 2 periods. If that's a little bit too long, back it off, 1. And we'll do something similar for the post-reaction data, except in this case we want to extrapolate it backward rather than forward. So maybe we'll try 1.5 periods. So now you can see our lines are extended out over the time of mixing where we want them to be. They overlap each other. We now want to clean our graph up a bit by taking out any data points we collected before the solution's temperature stabilized. And you can see our example has a point like that right here. This is at 3.5 minutes, 25.4 degrees. And we don't want to include this point because it was taken while the solution's temperature was still climbing, so it's going to make the post-reaction best fit line lower than it should be. And there's two ways you can get rid of it. If you come over here to the data group that makes it up, you can just simply delete that data point. There it went away, and you can tell the effect it had on the line. The line sort of climbed a little bit when I did that. There is a little bit of a more intelligent way to do that though. If we click on the data point, you can see it highlights the numbers over here. And instead of deleting the number, if I take the corner right here and pull that down, that excludes the point from the graph, but at the same time the data numbers themselves are preserved, and that way if you go back later and decide you want them after all, you still have them. Our next item is to use the best fit lines to figure out what the solutions before and after temperatures would have been right at the time of mixing, which again in our case is at 3 minutes. So I'm going to make this a little easier myself by zooming in a bit. Just drag that down. So if we look at the post-mixing line at this time, at 3 minutes, you can tell that it falls somewhere between 27 and 28 degrees. And if we interpolate between the actual lines, we can better estimate that. I see it at 27 point, maybe 7 degrees. And if we do something similar for the pre-reaction line, it's down here, it's a little bit below 22, it's maybe 21.9 degrees. And so the temperature change at the time of mixing is just the difference between these. That's going to be 27.7 minus 21.9, 5.8 degrees. And that's pretty much all you have to do to get your temperature changes. The graph for the dissolving of solid ammonium chloride into water may look different from this one, but the principles you use to get your temperatures will still be the same. And once you have them, you're ready for the enthalpy calculations.